Distance is a very important aspect when we learn about straight lines. You have come across the questions like how far apart, what is the distance between 2 points, and so on. A straight line is formed when we have 2 points. So, we know that when we take 2 points, a distance can be formed between those 2 points, right? Similarly, when we have a point and a line, a distance is formed between them. Similarly, if we consider 2 parallel lines, again, distance is formed between them. So, in this particular video, we are going to analyze the distance from a point to a line. Also, we'll be discussing about distance between 2 parallel lines. That is, how far apart. So, first, we'll be analyzing how to find the distance from a point to a line. In Euclidean geometry, the distance from a point to a line can be thought of as the shortest distance from the given point to a point in the infinite straight line. That is, that distance we can call it as the perpendicular. So, we are analyzing to find that length of that perpendicular. Alright, now let's start with drawing a graph. Consider x-axis and y-axis with origin at O. Now, what we need a point and a line, right? So, I am drawing a line. Let that line be ax plus by plus c is equal to 0. Now, we need a point. Let that point be P with coordinate x1, y1. Now, I need to join this point to the line. So, draw a perpendicular from P to the line and it joins at point M. Now, you can see that the line ax plus by plus c is equal to 0 joins the x-axis and y-axis at 2 points. It joins the x-axis at point Q and it joins the y-axis at point R. Now, we have to find the coordinate of this Q and R. Now, what will be the case at point Q? At point Q, we know that y-axis is equal to 0. Substituting in the equation ax plus by plus c is equal to 0, you will get the value of x. So, x is equal to minus c by a. Alright, so the coordinate of point Q will be minus c by a, 0 because the y-axis is 0. Right. Now, what about at point R? We know at point R, it lies on the y-axis. So, there x is equal to 0. So, substituting in the equation x plus by plus c is equal to 0, we get the value of y. So, y is equal to minus c by b. So, the coordinate of point R will be 0, minus c by b. So, we got point Q and point R. Now, what we have to do next? We have to join this R and Q to the point P. So, on joining, we get a triangle PQR. Now, we have to take this triangle PQR. If we take triangle PQR and I am considering the area of a triangle PQR is equal to, we know that it is half into base into height. So, what is a base? Which is QR. And what is the height? The distance, perpendicular distance PM, which is nothing but D. Right? Now, we are interested in finding PM, the perpendicular distance. So, PM will be equal to 2 into area of triangle PQR divided by QR. So, now we got an equation for PM. Let it be equation number 1. So, in this equation PM, we need to find area of the triangle PQR and also QR, right? So, let's find out first the area of triangle PQR. To find the area of triangle PQR, we have to use a determinant. And we know that point P coordinate is x1 comma y1 and point Q coordinate is minus c by a comma 0 and point R 0 comma minus c by b. So to find triangle PQR, the area is given by half into determinant of, write these coordinates as it is. So you will get x1, y1 minus c by a 0 in the second row, 0 minus c by b in the third row, and the third column we need to fill it with 1, 1, 1, 1. Now taking the determinant, we get half into, so we are taking the determinant along the first column. So x1 into 0 minus of minus c by b minus c by a into y1 minus of minus c by b. It will be plus c by b plus 0. We are taking the modulus value because the area always gives a positive value. So we have to consider the modulus value. So half into, expanding this, we get x1 into c by b plus y1 into c by a plus c square by a into b. Now again I can write taking c by ab as common. I will get a into x1 plus b into y1 plus c. Now in the actual equation we need twice the area of triangle PQR. So twice the area of triangle PQR is equal to 2 get cancelled. So modulus of c by ab into modulus of ax1 plus by1 plus c. Let it be equation number 2. So we got the area of triangle PQR. Now next we have to find the distance QR. How can you find? We know the coordinate of Q is minus c by a comma 0 and the coordinate of R is 0 comma minus c by b. So we have two coordinates Q and R. Now to find the distance QR, we can use the distance formula, which is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now substitute the value, we get root of 0 minus of minus, that is plus c by a the whole square plus y2 is minus c by b minus 0 the whole square, which is nothing but taking c by ab common, we get root of a square plus b square. This is our equation number 2. We got QR as modulus of c by ab into root of a square plus b square. So we got QR as modulus of c by ab into root of a square plus b square. Mark it as equation number 3. Now we have to substitute equation number 2, that is the area of triangle PQR, and equation number 3, which is the distance QR, in the equation number 1. So we get PM is equal to distance D is equal to modulus of C by AB. Cancel each other in the numerator and denominator. What is left? Modulus of AX1 plus BY1 plus C the whole divided by root of A square plus B square. And this is the equation we are finding, right? So PM is equal to D, which gives you the distance from the point P to the line AX plus BY plus C. So when you get a question, what you have to do, you have to analyze what is A, what is B and what is C, then X1 and Y1, which is given by the point P. Alright. So with the knowledge gained, we have to analyze next what is the distance between two parallel lines. And the peculiarity of the parallel lines is that their slopes are equal. We have to find the distance between two parallel lines. So let's start with drawing the figure. So you have the x-axis and y-axis, and I'm drawing two parallel lines. Let this be line L1 and another parallel line L2. Now let L1 be y equal to mx plus c1 and L2 be y equal to mx plus z2. As you can see, the slopes are equal, only the difference in the intercept, right? Now what we have to do is, we have to take a point, or we have to consider a point in the line L1, and we have to join that point to L2. We get a distance. We get a distance between the two parallel lines. So for instance, if we consider in this graph, we can see that line L1 touches the x-axis at a point. Let that point, let me mark it as point A, and it touches the x-axis. So we need to find the coordinate of point A. As the point A lies in the line L1, we know that in a straight line it consists of infinitely many points, right? And point A is one such point. Now what is the coordinate of point A? We have to find it, because y equal to mx plus c1, in that the y coordinate is 0. So what is x? X is equal to minus c1 by m. So the coordinate of A will be minus c1 by m comma 0. Minus c1 by m comma 0. Now join from this point A to L2. That means we have to draw a perpendicular from the point A to L2 such that it is perpendicular, right? Let this distance be D. Now if we find this distance D from the point A to L2, we can find the distance between L1 and L2. This perpendicular distance will give you, unfortunately, the distance between two parallel lines. Just now we have discussed the how to find the distance from a point to a line, right? We got an equation for perpendicular distance D is equal to modulus of ax1 plus by1 plus c by root of a square plus b square, and we have to use this equation in this particular situation, right? Now let's start deriving. So we have seen distance is given by modulus of ax1 plus by1 plus c, the whole divided by root of a square plus b square. Here also it is a distance, so we have to take only the positive value. So that's why we are using the modulus. Now in our equation, we have L1 is y equal to mx plus c1, and we have L2 as y equal to mx plus c2, and we got point A at minus c1 by m comma 0. So we have the distance D, L1, L2 and point A. Now we have the point A and the line y equal to mx plus c2. So from the line L2, we have to find what is the value of A, B and C. So taking y minus mx minus c2 is equal to 0, and comparing with the standard equation ax plus by plus c, we get value of A. What is value of A? That is a coefficient of x, that is minus m, and the value of B is coefficient of y, that is 1, and C is nothing but minus C2. Now substitute these values of A, B, C in our equation of D. So on substituting in D, we get D is equal to modulus of minus m into, what is your x1? x1 is your minus c1 by m, the x coordinate of point A, plus B is 1 into y1. What is y1? It is 0, plus C is minus C2 divided by root of A square plus B square, that is M square plus 1. M cancel and we get modulus of C1 minus C2 divided by root of 1 plus M square. And this is the distance we got between two parallel lines L1 and L2. So when you get two parallel lines, first take a point in line L1, join that point to L2 and find the perpendicular distance using the equation, and we got the final answer. We have derived the distance between two parallel lines. Now if we generalize L1, let it be AX plus BY plus C1 is equal to 0. L2 is of the form AX plus BY plus C2 is equal to 0. Then we have the perpendicular distance D is given by modulus of C1 minus C2 the whole divided by root of A square plus B square. This is a general equation to be used when you have two parallel lines and you have to calculate the distance between those two parallel lines, right? Now let's see one example. Find the distance between two parallel lines L1 4x plus 3y minus 8 is equal to 0 and L2 4x plus 3y plus 2 is equal to 0. So given two lines L1 and L2 and we need to find the distance between these two lines. So we have to use our equation. So what is the equation here? D is equal to modulus of C1 minus C2 divided by root of A square plus B square. So we have to identify what is A, what is B, C1 and C2. So what is A? A is coefficient of X, that is 4. And what is B? B is equal to 3. And what is C1? C1 is minus 8 corresponding to the L1. And C2 is plus 2. Now substitute in this equation. D is equal to modulus of C1 minus C2 minus 8 minus 2 divided by root of A square plus B square, that is 4 square plus 3 square. We get modulus of minus 10 divided by root of 16 plus 9, which is equal to modulus of minus 10 will give you 10 divided by root 25, that is 5, and we get it as 2. So the distance between the two given parallel lines is nothing but 2. So with that, we have discussed all the concepts related to distance to find the distance between a point and a line and distance between two parallel lines. Now let's do a quick recap of what we have discussed.
Manorama Horizon. Learning made simple.